Thank you very much. Now, we're going to move on now to our next session, termed Terror Tectonics. And the aim is to provide us with a much deeper understanding of the emerging technologies, some of which we've just been discussing, how they're reshaping our world and how they can be embraced for the benefit of our airspace and cyber power capabilities. Now, they include how we are increasingly embracing artificial intelligence and machine learning, and the progress from crewed to uncrewed systems. We're also going to examine the use of emerging technologies, including quantum-based capabilities and their game-changing potential, and our approaches to embracing increased human augmentation and enhancement within the military context. We're also going to cover the challenge of ever-increasing integration between systems of systems, and we're going to envisage future conflicts across 5 domains and within 4 dimensions, so including the length, breadth, and height of the battle space and its time-space continuum. So I would now like to introduce our speakers for this session. So first of all, we have Dr. Simon Harwood, UK Capability Director for Leonardo, focused on the utility of advanced technology in defence and security research. Welcome, Simon. Also, Tom Jones, who's President of Northrop Grumman Aeronautic Systems. So welcome as well to you, Tom. Mark Cole is a Director of ISR and UAS requirements at Lockheed Martin's Skunk Works, and was also a former Chief Instructor with United Airlines and a former Chief of U2 Operations and Programs and a U2 Instructor Pilot. Welcome. Also, we have Steve Reeves, who's a Strategy Head of Advanced Projects at BAE Systems. Welcome to you, Steve. And Dr. John Wills, who is Head of Sales for Intelligence UK and Airbus Defence and Space. Welcome. Now, taking the first presentation, please welcome to the stage Dr. Simon Harwood. And Simon, you can use the lectern over there. Thank you.
Well, good morning, everybody. Thanks for the opportunity to speak. As was introduced, we've been, as an industry panel, given the impossible task of explaining the increased usage of AI and ML, move from crewed to uncrewed, embracing human augmentation, emerging technologies, and, as was said, the multi-domain, multi-dimension sort of warfare in 8 minutes each. So we're going to skip through at a high rate. I'm going to do nothing more than sort of merely touch the surface, and hopefully throughout the next few days into Riyadh, Farnborough, we can get into a bit more detail. My background, in 2 seconds, I've spent 10-year portions in government, industry, and academia. And what I'd like to be, as my colleagues will tell me, is be a little bit controversial today, just to engender the debate. But let me start with a quote. I would like to have done, for honour of my Lockheed colleagues, I would have liked to have done a Kelly Johnson quote, but let me start with, in fact, Henry Ford. And he said, if I'd asked people what they wanted, they would have said faster horses. How do I interpret this? As we move into implementing AI, autonomy, augmentation, and other emerging technology, we have to think with a completely different mindset, as was said in the previous panel, to gain true advantage. Otherwise, we'll simply end up building faster horses. So I'm going to try and tell the story in 5 chapters, a minute a chapter. So number 1, chapter 1, the digital age. AI is a great acronym. Whether it's artificial intelligence, augmented intelligence, or applied intelligence, machine learning or autonomy, enhanced by quantum computing or not, the fundamental question to ask is, are we as a community prepared to embrace and accelerate this towards this inevitable future? Do we want to be first movers or fast followers? Which gives us the greatest operational advantage? The industrial age, or otherwise known as Industry 3.0, demonstrated excellence in hardware, software engineering, automation, computers and electronics. Moving into the digital age, Industry 4.0, it's about cyber-physical systems, Internet of Things, networks. This is the new reality, as we heard previously. But this is about new skills, people, processes, business models, attitudes to development, deployment, and operations. It requires all of us, business and government, to reconsider the internal processes that we've got and the way in which we deal with the relationships between us. But digital transformation is not just about technology. Digital transformation contains a multitude of different decisions that all have to be made in an interconnected way. A great big long word, socio-technical interaction. It's about all lines of development. The wicked problem, though, and I hate to break this to everybody, is that we're all on this journey together. Industry's no further ahead than government. We're all going forwards and learning as we go forwards. And the one thing I want you to take away from this speech is it's us as a defence and security sector, because we're actually competing against pharma, oil, gas, motorsports. So, yeah, we all do compete against each other, but it's us as a community that have to work together to make it differently. Chapter 2, thinking differently. At the risk of upsetting everybody in the room, an aircraft, satellite, it's simply a cart or a taxi cab for the sensors and effectors. And what we've generally done over a number of years is make the taxi cab faster, stealthier, heavier, and then replace the driver with a computer. All of this has led to increased cost, hence less platforms and arguably vendor lock-in. What about the opposite paradigm? Why not put lots of expensive sensors on lots of cheap platforms, or even put lots of cheap sensors on thousands of cheap platforms? I always make the very unfunny joke, how many Spitfires would it take to destroy an F-35? I'm betting not that many if you put a wall of them in front of them. But, not to move away from the fact we still need those high-end platforms, but it's just a different force mix in which potentially we need to do it. So to make it more real, let's use the example that many of you have been through about airborne and command and control from an orbiting platform. Or should I buy a system of systems of connected sensors to do the same job? People will argue about positioning, radar power, platform availability, tasking, etc. But the truth is, with emergent technology, AI, ML, autonomy, and other emergent technologies, coupled with a thorough examination of the lines of development, we're on our way there. We can do that, or we could do it soon. Chapter 3, for those of you familiar, I'm going to call this one The Emperor's New Clothes. It's a fable about not everything is as it seems. So on emergent technology, let's go very quickly, one by one, and I'm not going to do them justice. But back to my first statement. Are we first mover, or are we a fast follower? Who's driving these things? Is it the civilian market, or is it the military market? Steam to flight, to rockets, to satellites, to electronics, to autonomy. Sometimes we must follow, other times we must lead. Quantum computing, let's dispel that. The real truth is, in most instances, as far as I'm aware, quantum computing really remains a wish. In the recent McKinsey report, it's going to be 10 years before we really reach mass adoption of sort of quantum technologies, and happy to hear differently. Autonomy, on a 10-point scale, we're probably at about 7 or 8 in terms of autonomy, full autonomy being sort of 9 or 10. To get to that point, we need greater computing, sensing, and actuating capabilities. I actually suggest the scale should probably be up to 12 or 13 once we consider AI. Talking about AI, and is it applied, augmented, or artificial? On a scale, there's sort of 3 levels, from dumbest to smartest. Applied narrow intelligence, chatbots, Alexa, Cortana. AGI, artificial general intelligence, that's about recall, hypothesis, and analogy testing. And artificial superintelligence. We're probably at the level of AGI. We haven't reached artificial superintelligence, and that's when it starts to surpass our thought processes and our ability. So in summary, let's be careful of claiming about emergent tech. Let's back it, but let's be realistic about what it can do. Very quickly, trust in AI. Previously, we've talked about humans maintaining meaningful control in order to trust. That's going to be no longer adequate when responding to the advances in AI. So we need to think how we trust it. Quickly running through Leonardo. At Leonardo, we do build platforms, helicopters and UAS, but we're moving towards this vision of cognitive intelligence sensors. Sensor network that is cognitive, means it's able to make sense of the data and interpret it. Autonomous, in the sense that it's capable of making decisions and learning from experience. A sensor network, in the fact that it can acquire data about a particular area.
and cognitive in terms of, as I said, interpreting it in that sense. The system itself acting as an artificial intelligence sensor commander, meaning the system puts the right sensor in the right place at the right time, rather than collecting lots of meaningless data and post-processing it. We see this as OODA 2.0, where the observe and orientate are a largely automated task. To do this, of course, we need, as I mentioned, suitable taxi clouds to deploy the sensors and a robust network to passage the data. Not forgetting we need to obviously maintain and improve the fidelity of the sensors themselves. So in summary, we're creating the next generation of cognitive intelligence sensors, associated multi-domain integration architecture, and tactical systems. Finally, I think to takeaways, chapter 5, the to be continued, the four big things we need to address. We need to work together, co-creation, led by science and technology, research and development. We need to work out operational independence versus freedom of action, as we've seen through Ukraine. What does this do for supply chain? People and skills, more, and intellectual debate. Let's be real about some of the technologies and how they might affect us. Thank you.
Thank you very much.
All right, thank you very much. I'd like to begin by thanking you all for the opportunity to come here and speak to you this morning. It is indeed humbling to have the opportunity to talk to so many men and women who have risen to the pinnacle of their respective services here. I'm also, for those of you close enough, might notice I'm wearing a RAF tie today, even though I am a Yank. That's actually not just out of respect for our host today, but also in honor of my father and grandfather, who were both members of the RAF. As I reflected back on that family heritage and this august group I'd be speaking to, I was wondering a little bit about what I could bring in this talk that would be of value. And it occurred to me that possibly as a lifetime engineer who's never worn the uniform, perhaps the perspective of someone who started in my 20s in the basement of a university working artificial intelligence algorithms, spent my 30s in boats chasing autonomous underwater vehicles around oceans. In my 40s, led a research and development organization that tried to figure out how to advance cutting-edge technologies into applications for mainline defense acquisitions. And now, in my 50s, I'm sitting here trying to figure out what the right bets are to invest in terms of where you as our customer and our nations need to go in order to offset the adversaries. I think that's perhaps appropriate given the fact that we are at this critical juncture looking at bringing on these new and revolutionary technologies, as the previous panel talked about. A few books just for your reference that might be of interest, things that I've been reading lately. The Age of AI and Our Human Future by Henry Kissinger. Great book talking about exactly what Dr. Roper mentioned in the previous panel about how AI really solves problems in a way that is uniquely unhuman, and how we as humans are going to figure out how to trust and interact with that. Beyond Pixie Dust, an excellent report by the Mitchell Institute, looking at how we can adopt autonomous systems into our force structure. And then finally, AI Superpowers, which looks at China in particular and how they are responding to the AI revolution. So I have 3 points that I want to cover today. The first one is JADC2, Joint All-Domain Command and Control, and artificial intelligence is coming, and what does that mean? I think, first of all, just the introduction of JADC2 in and of itself, and the concept of any sensor to any shooter, figuring out how to get much more out of our data, drives to a use of AI and analytics at the edge, and that will bring further problems of integration into the warfighting force that I'll talk about in a little bit. I think also as we look at JADC2, the ability to bring space components more clearly into the fight and running the aeronautics sector, I have kind of a uniquely airborne perspective. Later on today, my boss and the CEO of Northrop Grumman will kind of give an overall perspective of Northrop Grumman and our view on technology and how we're going to advance technology into utilization. If we look at the airborne component, I think one of the things that we've seen recently in Eastern Europe is the continued value, even with lots of critical information coming through space ISR assets, but the continuing value of persistent regionalized ISR and BMC2 and the airborne layer. And we see that through the use of things like NATO AGS and AWACS and other platforms. And as we go forward and look at how that capability needs to map into the future, we need to figure out how we can make that airborne ISR layer both able to function with space and other ISR layers, but also how to make them survivable. And I think another great example coming out of NATO is the NATO AFSC program, which we're working currently with our partners at Airbus, which is looking at disaggregated airborne early warning and control. I think also as we look at autonomy and coming, this is really a race. I think Dr. Roper and several other speakers in the previous panel mentioned the fact industry, our adversaries are moving out, and we really need to figure out how we can very rapidly adopt this technology into what we're doing. Which brings me to my second point. It's not really about the technology at this point. From my perspective, this is really about the trust in the technology itself. So there's a couple pictures that are flashing up randomly behind me as I speak. The one that's on the screen right now is actually the X-47B, which in the early teens, I think 2013 and 2014, was doing autonomous launch and cat traps and aerial refueling for the US Navy, demonstrated a lot of great autonomous capability. And yet when we were done, there wasn't an identified use for that. And the Navy continues to work with unmanned platforms, aerial and undersea, even to this point. I mentioned earlier on that I used to work in the autonomous underwater vehicle industry. Lots of great demonstrations going back even into the 90s that we did with autonomous technology there. There's always a level of trust and concern with how those technologies could work. In fact, the common joke with a lot of my military customers that they used to like asking me was, what's another name for an autonomous underwater vehicle? And the punchline is lost. So, this whole, do we really want to put our lives at stake for this machine that we don't understand exactly what it's going to be doing? I think also from the point of JADC2, there's another example where I believe there are a lot of test cases and applications we could use to demonstrate the applicability of all domain command and control and have real effects. But we've been wrapped up kind of in a big bang approach as opposed to more of an agile, spiral, DevOps type of approach where we test a little bit, deploy a little bit, and go forward. In a conversation this morning, someone made the point, did anyone sit down in the 1960s and 1970s and say, let's design an internet complete with streaming music and streaming TV shows and everything else that exists? No, it was developed a little piece at a time. We've had different communication layers in terms of cellular or broadband come in that the applications lay on top of. And as that technology has advanced, we've been able to build better and better applications. And I believe JADC2 is in that same place where we really just need to go out and start implementing some of the cases that the technology allows us to do now. I think this is particularly appropriate for this group of air chiefs because we need champions. And the champions we need, I believe, are seated in this room right now. And what is it we need champions for? I believe we need champions to help us start moving forward and addressing what I would call some of the harder problems of adopting all domain command and control and autonomy and artificial intelligence into our ConOps and how we go forward to fight wars. In many cases, like I said, it's trust, it's policy that is just as much a limiter. We can do as many experiments or demonstrations as we want to that show that AI can do this or that. I would argue we've already demonstrated that there's enough capability in AI that we could have a positive outcome if we integrated some of that capability into our current warfighting structures. However, what about trust? if you go to the most basic level, cognitive EW is going to be very good at helping us be able to deal with adaptive waveforms and agile waveforms our adversaries are using. We need to make sure that the pilots that use these systems have confidence that these systems are making the right decisions, even when the decision process that these systems go through is illogical to a human user. In terms of JADC2, frequently security policy and what data can be shared across networks and shared with what users is the limiting factor in what we can actually do in terms of JADC2 applications. I mentioned trustable AI, airspace management. That's a huge issue if you think about unmanned loyal wingmen operating in close proximity to manned aircraft. How can we make sure that these systems, which may be operating with AI or maybe just advanced automated state machine types of implementations, that it's trusted? And then we go to certification agencies and deal with how now are we going to get a unmanned aircraft, possibly with autonomy, once again, that is decision-making is opaque to human users, certified as being airworthy and being able to fly in public airspace, let alone in close proximity to warfighters. So in conclusion, I think that the technology we need to get started on is here, and that's important because we are in a race and we do need to get started if we're going to keep pace with our adversaries on this. Integrating these capabilities is more than just the technology. It's working the cultural issues, it's working the certification issues, it's working the concept of employment. And that is an area that I think that we can make a lot of progress on in parallel with the technology and are things that we are going to need to do in order to make sure we can integrate this capability. So thank you very much.
Mark, would you like to go up?
Sure.
Thank you.
Good evening to everybody out there. If I could have my first slide, please. In the Skunk Works, we're known for solving urgent needs and inventing only that which needs to be invented. And what we heard in the previous panel was that technology is moving faster. So if I could have the first slide. I'm going to talk about the work that we've been doing to enable MDI and JADO, and then how to leverage that work for crewed-uncrewed teaming. And so if I could have the first slide, please. So when we look at enabling MDI and JADO, we kind of start with the end in mind. And so if you look to the far right and you see the description of what that future environment looks like, fully distributed for survivability, resilient systems, we're putting humans on the loop. And so when we start with that end in mind and we say the technology is here, then what is it exactly that we're doing? And we're looking to see how we operationalize it. And we have taken kind of an incremental approach. So from a three-step process, we look at maturing the foundational technology. You see the technology stack there that we're working with. Then take those technology and do incremental demonstrations of increasing complexity over time. And so we are tackling the problem one bite at a time and building on that complexity. And then after you do that, after I've demonstrated that capability, then now I need to move it and map it to those specific platforms to realize that capability. And later on, we'll have another speaker that talks about a specific implement. But as you see on the bottom row here, you see a series of demonstrations. And what they show is the ability to work not only across domain, but across generations of capability. And so it's that working cross-domain, working cross generations of capability, working across services, which will give us the ability to enable that coalition force. So we really do believe that the technology is there today. So what underpins that? What allows us to do that? And a lot of it is embracing standards. And so we haven't really talked about standards yet up on the stage. And so these demonstrations, we call them the Open Mission Systems demonstrations because they're based on a standard in the U.S. Air Force Open Mission Systems unit using a government-owned message set, which is the UCI message set. And so what that does is if everybody's on the same standard and everybody's using the same message, it gives you the ability to work across companies. It gives you the ability to work across services to enable that future capability and to do it successfully over time. So if I could have the next slide, please. So then how does that work for enabling crewed, uncrewed teaming? And when I look at this slide, I kind of look at the left and the right as the why and the how. And so the threat is driving the need for that seamless integration. So we see survivability as a key component moving forward. And the resilient integration, the ability to provide the adversary a problem where they have to attack on multiple levels. You know, what will effective teaming do? Well, effective teaming, as we move forward, transfers risk first and foremost. I want to transfer that risk from the crewed asset to the uncrewed asset. And as I transfer that risk and I transfer part of the task, then I free up the crewed asset that basically extends range and capability over time. And that accelerates the mission success timelines. By using multiple assets and multiple domains and doing them and connecting them seamlessly, I'm able to move quickly and move from one mission goal to the next mission goal. And the solution set's an evolving set of capabilities. And earlier, Dr. Roper talked about digital transformation. I'll talk about that is fundamentally one of the tools that we're using to enable this capability moving into the future. So how do you do it? And much like we did when I talked about enabling JADO, we're using that same approach in enabling crewed uncrewed teaming. It's a phased approach. We're going to leverage all of those JADO technology stacks, but then you have to add to it, you know, additional technologies, human-machine interface. How do I give the pilot the ability to control the uncrewed force without increasing the workload on the pilot? And where is the right place to do that? Earlier when I talked about the environment of human on-the-loop decision-making, where we embrace the technology to provide the operator the ability to seamlessly make decisions, only those decisions which we need the human to do, and provide the operator the integrated and fused position with multiple courses of action. You know, autonomy we've already talked about, but artificial intelligence. In the work that we see, we see an approach where we have a service-based architecture where our ability to integrate AI as it develops over time is enabled by those open standards that I talked about earlier. And then digital transformation. Digital transformation gives us the ability, as we look at the picture in between, and I love this picture, it's a great picture, but hopefully we'll never ever think that we're going to fly this way. But part of this capability is a rapidly changing fleet of uncrewed assets, and digital transformation gives us the ability to drive that cost lower and lower, and put new requirements and output new capability in very short periods of time. And then fielded human-machine trust, and we talked about trust, you know, with the last speaker. And so what do I mean by fielded human-machine trust? So in the Skunk Works, we developed something called Automatic Ground Collision Avoidance System. And to date has 11 saves. And for those of you that are familiar with it, you might think, well, that's a crewed asset capability. What does that have to do with crewed uncrewed teaming? But take what we learned with ground collision avoidance system, which is if something happens to the pilot, don't let the weapon system hit the ground. Save the airplane, save the pilot, most importantly. And then we translate that to automatic airborne collision avoidance system. So now I'm saying, don't let that airplane hit another airplane, and very specifically, if I'm talking about an uncrewed asset, don't let it hit me. And then move that, one step further into, okay, now if I can automatically not hit the ground and not, hit another airplane, can I now, reverse that and go, can I track and very specifically do a combat task with it? Early in my life, I spent a bunch of time as a primary flight instructor, and very shortly from a new student showing up with almost no flying time, 4 months later, they're off your wingtip solo in about 90 degrees of bank, and over that time you build a significant amount of trust. And so I think a lot of the trust equation is very similar. It's not different, it's the same equation, but we're putting it in this autonomous system, which is, I would tell that student, don't hit me, don't hit the ground. And now in this future autonomous crewed uncrewed teaming, now we're going to teach that how to attack another asset. So when I look at the future, or when we look at the future, we see this diverse, and distributed capability set with survivable teams and survivable teams where we move it forward with resilient communications. They enhance the effectiveness. A lot of folks get into, what is the right mix? What is the right mix of crewed and uncrewed asset? And it really depends on the mission. It depends on the assets that you have available and the ability to compose a force structure in the day that defeats what or presents a more challenging problem to the adversary in front of you. And it provides that operational flexibility and that asymmetric advantage that we're going to need in the future fight. So just kind of in summary, we really believe the technology is here. We believe that technology is across domains, across generations, enabling the coalition force. What are the challenges if the technology is the challenge? And no surprise to this group that their cultural challenges, their policy challenges, those are the challenges that we have to address if the technology is already there. So, and if happy to take questions as we move further on. Thank you.
Global chiefs, ladies and gentlemen. The world, and with it, the character of conflict, is changing incredibly fast. The definitions around the volume of information defy common logic, but to put it into some perspective, 90% of the world's data has been created in the last 2 years. We send 300 billion emails a day, and if someone was to try and download all the information on the internet, it would take you over 180 million years, probably a bit longer from my dodgy connection in deepest Devon. We've become really good at creating data, but probably not so good at exploiting it, particularly at volume and particularly in near real time. So as we heard earlier, our decision time, whether you're an operator or whether you're an operational commander, is being eroded. And for all our best efforts, the fog of war isn't particularly receding. And across the 5 domains of air, land, space, cyber, and sea, they're becoming increasingly intertwined and interdependent. And all of that is making understand and decide increasingly difficult. If I could have the next slide, please. So the art of war needs to continue on its set path to more ever joint, cross-government, and cross-coalition. And we need to get even better at knitting together information from all the way from open source to above secret in near real time. As we heard in the TED Talk, the approaches of yesterday are not going to be fit for the challenges of tomorrow and arguably aren't even fit for the challenges of today. And recent events have shown us that we live in a contested world, a multipolar world, where not everybody wants to play by our rules of the game. States and clubs of like-minded states are becoming more competitive, and we're seeing the influence of our global institutions under threat. All of this is a reminder that defense sits at the heart of the foundation for society. And within that, I would argue, sovereign capability is becoming ever more important. Now, the application of AI touches many aspects of our lives, and we've already heard about some of them during the previous talk and previous speakers, whether that's finance, marketing. I'd probably add the development of COVID vaccines at pace to that particular list. And if we look at autonomous vehicles, then, making great strides in many areas, whether that's vehicles on the ground or air systems as they move from demonstration to operations through global companies. And as Mark has said earlier, trusted autonomy is becoming the key. And the pacer isn't going to be about technology, it's going to be about policy and how we turn that policy into concepts of operation. And proliferation of these systems is going to mean that they're going to have to become ever more interoperable to give us all the force mixes that we'll be dealing with, integrating today's technologies with those of the future. So our open architecture is going to be a key characteristics. Building great aircraft is great fun, nearly as good as flying great aircraft. But at the end of the day, this is just going to be a shell, and we don't even have to worry about all the aspects of life support. I'm not saying it's easy, but I think where the magic happens is going to be turning that platform into a true capability. And to do that, there's going to be a blend of goal-based autonomy or mission command, and we're going to have to harness with that resilient systems that will provide battle space management and multi-domain networking. All that requires quite a high level of sophistication. Could I have the next slide, please? Thank you. So I think uncrewed air systems offer the opportunity to either augment or substitute, as much as the customer wants, across all the roles of air power, whether that's ISR, mobility, attack, or control of the air. And there's going to be a great range of choice, whether that's the small nano type of operations, all the way through to high-end technical survivable platforms coming down the line. But throughout all of this, partnering is going to be key. That's partnering with customers, but also partnering across industry. That's how we're going to get best athlete solutions, and that's how ultimately we're going to get the best products to the warfighter. Now, for our part, BAE Systems intends to build on our rich heritage in this sector and develop a family of UAS options. And I'm delighted that we'll be showcasing some of our concept designs for the 2025 era at RIAT, and hopefully many of you will have the opportunity to come and see them. So in summary, uncrewed air systems are here to stay. They're going to be part of our force mix, and I think they offer the potential for affordable combat mass. Yes, they can help reduce risk to life, just as remote piloted or standoff weapons have done before and will continue to do so. But ultimately, the calculus around risk to mission and risk to reputation is going to remain. So in that sense, it's the same but different. We're going to see ever more uncrewed systems in our effective force mixes, and you're already starting to see that, I think, in today's systems where they're showing utility. But the journey in the next few years is going to really be about adding operational capability and ultimately about helping to bridge the gap to sixth generation capabilities where information really is going to be king. Thank you.
Thank you very much, Steve.
Okay, firstly, thank you very much for the opportunity to come and talk to you today. I realise that I'm almost the only thing between you and lunch, and if, like me, you're ruled by your stomach, you won't want me to waffle on too long, so I'm going to try to be brief and proceed at pace. I'm going to focus my points on space-based ISR and the rise of artificial intelligence and machine learning in the context of satellite-derived Earth observation data. First slide, please. There are some key points to make here which complement what has already been said. And the first point is that you'll no doubt have heard a lot of buzz in the media about both the thousands of commercial imaging satellites that are going to be launched and the numerous problems that are going to be solved with artificial intelligence and machine learning. The point to make is that there's a proliferation in the number of individual satellites and constellations that are due to be launched. And many are from new space players, but others from existing operators such as ourselves, Maxar and Planet. And in terms of Airbus's own constellation, we've invested almost €1 billion of our own money on our new 30-centimetre Pleiades NEO constellation, but also investing in smaller UK satellites from a subsidiary SSTL and in RF data, for example, through Hawkeye 360. Similarly, we're investing heavily in artificial intelligence and machine learning. And ultimately, it's about finding the most efficient way to provide customers with actionable intelligence. Next slide, please. So I'm making a few key points here, and the first of those is about what I term the data tsunami. all of the new satellite constellations are going to produce literally a tsunami of data, and it's already happening effectively. And there are simply not enough image analysts or hours in the day to process and exploit all of this data, even if half of these satellites don't end up getting built or making it into orbit. Moreover, when I hear about similar trends in the UAV sphere, it's clear that there's a proliferation of collect capability and a real lack of capacity to exploit the data. The old ways of working simply won't suffice in this new world. The associated point here is that even if we had enough analysts, we probably couldn't sift through all of the data to identify the important trends and the key nuggets of information in time. And even if we could, we'd probably be too slow and miss some or all of the benefits of near real-time tasking and collection, or the ability to tip and queue between sensors, as we're already starting to do, for example, between RF and SAR or electro-optical data in some of our current services. The next point to make is that much of the current push for artificial intelligence and machine learning is actually coming from the commercial sector, which is then feeding back into defense rather than the other way around. We have, for example, been monitoring the car parks of major retail chains around the world for our finance customers for 10 years or more. So this is not a particularly new trend. What is new, however, is the speed of change and the proliferation of AI companies and interest in AI and machine learning. And this brings me to my next point. It's clear that the war in Ukraine has really been a game changer in terms of the visibility, the awareness, and the use of commercial imagery in defense. Surprisingly, though, at least publicly, this has not really yet spilled over into the artificial intelligence and machine learning side. But it certainly has changed perceptions of what commercial EO data providers can offer, and I would expect the use of AI and ML to increase as the war drags on and the benefit in terms of the speed and efficiency become clearer. The next point is that, as with all buzzwords and overhyped areas, there are people overpromising, and that, I think, does no one any favors. Don't get me wrong, there are some great companies and some great people doing great things, and there's some groundbreaking work being done. But the point is that there's no need to overhype, obfuscate, or hide the truth about what's possible. It comes back to that trust element that was talked about earlier. In the conversations that our teams have with customers, they need to know how it works, how reliable the answers are, and to really get under the covers. How do you get to that answer? And from that, even if we can save just 50% of the manual effort involved in completing a task, or we can complete some analysis that we simply couldn't do quickly enough manually, then that's still a massive saving and a massive benefit and a huge efficiency gain. So please, we have to cut through the hype and have an honest, open discussion about what's possible now and what will be possible in the future. Which really brings me to the key point. At the end of the day, if we don't understand with absolute clarity the question we're seeking to answer, the problem we're trying to solve with AI, no amount of AI expertise or EO data or other things will actually get us the solution we need. The more specific we can be with our AI in terms of the question we're asking, the more successful we will be. So very quickly, I just want to highlight 3 examples of some AI-related work that we've been doing in terms of operational services. In the top right, we can see, I'm sure many of you will recognize, even though it's rather small, Kabul International Airport. And this is an image taken during Operation Pitting back in August 2021, where we captured a large volume of Pleiades 50-centimeter resolution satellite images and analyzed these in near real time using our commercially available aircraft detection and classification models. And the resulting information was provided to a number of our customers involved in the evacuation. In the bottom right, we can see a Pleiades image of the Krakowec border crossing between Ukraine and Poland, taken on the 26th of February. Again, we ran 2 of our commercially available AI models for car and truck counting in this case to determine the number of vehicles queuing to cross the border and the likely number of people waiting to cross. And this information similarly was shared with relevant organizations and authorities. Finally, in the bottom left, we can see a TerraSAR X SAR image from our UK Maritime Service, which provides UK AIS-matched vessel detection reports delivered to the customer in under an hour from a satellite overpass. And this simply would not be possible with a manual approach. And without the underlying algorithm, it just wouldn't be possible to do that in the speed required, with the proven accuracy required or the volume of data processed. So my final point to come back to is that we're very proud to be supporting the UK's MOD, the Space Directorate and the Space Command on the journey to develop the UK's sovereign space ISR capabilities. But this is something of a plea that we don't only focus on the space assets, important as they are, but also on the processing and the exploitation of the data to ensure we get the answers to our questions and the solutions to our problems. AI and ML have a very important role to play in that, but we must focus on the questions that we're trying to answer. Thank you.
Well, thank you very much to all of you. It's been really fascinating. We do have a few questions that have come in from the audience. So first of all, this is from Richard Knighton, who says the MOD's chief scientific advisor often says that when we hear AI, we really should hear applied statistics. When war is episodic and involves irrational actors, how do we train our models? And Dr. John Wills, could I assume you've talked about the fact that we're going to get this data tsunami, and of course we've got a lot of erratic data in times of conflict. How should models be trained?
Yeah, well, I think having access to a large volume of historic data is really key. But also, it's coming back to those questions we're answering. Computers are really bad at doing vague tasks. If you can be really specific about the question you're answering, then it will work well. I mean, there's probably a debate as to whether we are talking about an irrational actor. If you, again, maybe not even with an AI approach, but if you look back at behaviors over the last 20 years, this was no surprise to a number of people. But certainly AI can play a role in spotting some of those trends, and obviously some of that has been done behind closed doors.
If I could maybe pile on there, I mentioned different areas where I think the services could help industry really further technology, come up with more robust data is definitely one of those areas, right? I mean, if you look at any learning system, neural net, deep networks, the quantity of data is directly correlated with the robustness of the solutions. Absolutely. So when we're working with data sets that are very restricted due to security classifications or other reasons, that can really hamper the ability to come up with robust types of solutions in AI. So I think that's another place potentially that we could work together between the services and industry to try and increase robustness of what we deliver.
Mark Cole, I can see you nodding as well.
Well, no, I mean, I would take it to the rest of that question was about training. And so when we look to this future force, which is using these new capabilities, plus we're using mass that we talked about, and that training is going to require a very different approach to training with a lot of synthetics, because I may be able to go out and train with a small number of uncrewed teammates, but what if I need to fight in the hundreds or more, and I need to employ these AI technologies? I'm going to need to be able to train that way, and I need to be able to do that synthetically, because I'm not going to be able to practice that way physically.
Okay, thank you.
Could I throw one more on there? I think because the question also asked about the vagueness and the fog of war, right? And I think one thing to make sure we keep in mind is what AI is good at and what it is not, right? So inductive reasoning, being able to draw conclusions of broad, disparate sets of data is not really where the state of the art is right now. It's more being able to recognize patterns that might elude or be very difficult due to the quantity of data for humans to do. So, at least from my perspective, I see continued need to have human interaction with these AI agents. We create autonomous systems, which again gets back to how do we develop the trust in these systems over time?
You've just segued very nicely onto the next question, because, of course, trust has featured very heavily in all of your presentations. And we have a question through. Trust and autonomy is a key theme here. How do air forces generate the required authentic trust in such systems? What are you doing, Steve, for example, to help generate that trust?
Well, I think it's about going on a journey together and taking those first steps. So we could spend an awful lot of time trying to map out everything to exquisite levels of detail. And I think for me, it's about trying to work hand in hand to chart a path through steps that we're all happy taking together. So for example, if you looked at autonomous systems, you could start with non-kinetic engagements, non-lethal activity, probably around ISR, perhaps into mobility, and then in time grow that into attack and then into the kind of control of the air-to-air engagements. That would be one way that we're looking at doing this.
Simon Harwood, is there anything you can add on that?
Yeah, I would just say, trust of AI systems is just like trust of humankind. I don't meet a random bloke I meet down the pub and trust him instantly. It takes a period of time in order to build that trust through working together, relationships and things like that. And it's the same in terms of the attribution to technology. It's about dependency, it's about proving oneself. So as Steve said, it's about going on that journey. But just to come back to the last question very briefly, we are hugely underinvesting in the use of synthetic environments and validation and verification. They say all models are wrong, some are useful. So it's about, as Steve again said, working hand in hand with the customer to put in meaningful data so we can validate and verify that so that we can then develop the trust and then employ it. But I would briefly say that the paradigm, as I said in my speech, the paradigm about trust between how we trust AI systems today and how we're going to trust them tomorrow, it's about 180 degrees from we've got to fundamentally shift that level of trust.
So how do you shift that? So trust and autonomy is a key theme here, which is this question that's come through. John, what's your take on this? How do you really boost authentic trust in such systems?
So I think it has to be scalable. And so built into our fundamental design concept at our uncrewed stations is the ability to scale the autonomy up and down as I build the trust. And that's no different than autonomy that exists in cars and airplanes now. As I learn to trust the system, I'll engage it more, I'll use it more, and that's scalable. So as we move forward and we provide the operator the ability based on their proficiency, the mission set, and the environment at the time to scale the level of trust that I put in the system for that particular mission.
And just focusing on that very quickly, it depends where you put the algorithm within the system. It's a very different level of trust if you're going to let it release weapons. Mm-hmm. It's a very different level of trust if you're going to simply get it from point A to B. So it's where are you putting that trust within the system?
Okay, well, so much more to discuss. That is all we have time for. It is time for lunch. We didn't get to all of the questions submitted for this session, but we'll use some of them in the later Q&A session this afternoon. But it's been a really fascinating. Thank you so much for all of your presentations. Now, it really does lay a firm foundation for the specialist sessions after lunch. We will be starting back promptly at 1 p.m, so 1300 hours. So if you could take your seats a few moments before, that would be much appreciated. Thank you.